Welcome to my third video in our fourth chapter for our Unity ActionRPG game project. And in this video, we're going to make some levers and give the player the ability to interact with things. And so you can see all these wonderful layers that we loaded up in the first video. And in this video, I'm going to make one based off this blue lever. And you can see it has different states. I'm only going to use the left and the right state. I guess if you wanted to have, you'd have to retool some of how we store the data to make use of the middle state as well. Because since we're only keeping track of true and false, then we've really only got two positions for the lever. So, okay, we need to start making a lever so that we can interact with it. But I guess before we even do that, we do need to start building the infrastructure on the player to interact with things. So that's going to take us to the player prefab. I'm going to open that up. And while we're talking about prefabs real quick, one of the things that may make your life a bit easier is changing the order that the scripts appear in. Because if you're trying to change some properties on like an enemy inside the world, like the skeleton script is all the way down here, which is incredibly annoying. But if you go to like the prefab, you can you can go to the little triple dots and do move up so that you can move up certain scripts higher in the order, which may make it easier for you to configure your levels because you're probably going to need to have these variables pertaining to the AI towards the top, which makes things a little bit easier to deal with. Because now when I select on a skeleton, you can see that the top script is, aside from transform, is the actual skeleton code and where all those important variables are. Because we don't really need to play with the animator, we don't need to play with the sprite renderer, we don't need to play with the colliders. So like once all that has been built, we really don't need to interact with a lot of that other components. All right, so let's go to the player prefab. And I'm going to do the same. I'm going to bump up the player script towards the top. Even though the player script isn't necessarily what I want to be taking a look at. So I'm going to need to create a child object on the player. And this thing's going to have its own collider to detect things. So let's right click on player and do create empty. And that creates a child object that's empty. And I'm going to call this interaction sphere. And this is basically the field of interaction for the player. And so I'm going to give it a physics 2D circle collider. So a 2D collider for circles. And I'm going to make this have a radius of, let's go 0.9 looks good. And then also we may want to consider doing some of the offset like negative 0.3. That does lead me to want to drop this down a lot more to maybe 0.7. So that's the radius in which I can interact with things. If we go turn on is trigger, then it won't bump me into stuff. Okay, I wonder if that's approximately where my other collider is. Oh, it's negative 0.36. Perhaps we should do the same. We go with 0.7 on that. All right, and so this is going to be what we're going to use to detect things that are interactable. And in a lot of games, they usually pop open, they pop an icon above the player to indicate that the player can use something. And so I'm going to do that as well. I'm going to create another empty child here. And I'm just going to call this E-key visual. And this is going to just be a floating E above my head, basically. So all this is just default. We're going to go to components, rendering, sprite renderer. And the sprite that I want to give it is inside of our textures UI keyboard. This is that stuff that we imported in that first video. And I'm going to do the E key here. I'm going to change its offset to be a Y of 1 so it appears up here. And the order in the layer, well, I don't really feel like dealing with the stacking order, so I'm going to set it to 30,010 so it should appear on top of everything. Debatable if I want to move it to the damage text layer as well as a thought. Okay, so we have this floating E key that's going to appear over the player's head. I'm going to turn it off. And so the idea is that this interaction sphere is going to have a script that when it detects something that I can interact with, which is going to be based upon this interactable tag that we created back in the first video chapters. And if there's an interactable object within this radius, it's going to show that. So let's start making a script for this. And so that's going to be inside of the players. And I'm going to call it C# script. I wonder where that appeared. I don't even know if it made it. I'm going to call this player interaction, no spaces. And then double click it to open it up. All right, so the player interaction script is going to need to not do a whole lot, but first let's set our public sprite renderer. And this is going to be the E key game object. And that's going to link us to this E key visual. So that we know that that's going to be attached there. Inside of start, we're going to choose just the E key. We're going to set E key dot enabled to be false. Now keep in mind this is the sprite renderer we're interacting with, not the entire thing. So it's just going to turn off the appearance. Then we need to, whenever we enter, so private void on trigger stay 2D. Rename this to other. So if other dot compare tag, if it's an interactable, if that's how we spelled it, we'll find out shortly enough, then E key will be enabled is true. And then we're going to do when I on trigger exit, kind of the opposite. So private void on trigger exit 2D with the 2D collider of other. And if that isn't interactable, if we left an interactable, it'll set the E key visible to false. Now if we're standing in the radius of 2 switches, well yeah, when we leave one it'll try to set it to false, but there's another switch that we might still be in the radius of that will set it back to true. So this will be a pretty foolproof way of handling that. But we don't really have anything that's interactable yet, so all we've really done is created this thing that will pop up that E key graphic. So let's attach that to this interaction sphere, the player interaction script to the interaction sphere. And then let's attach the E key visual into this E key part. And so now the player's got everything it needs right now to start sensing if there is interactable things around the player. Remember that this does need to be an is trigger, and we do not have a rigid body here. This is just for sensing switches. So that's not going to be even noticeable right now until we start building a switch to interact with. So I'm going to right click and create empty. let's call this lever parentheses blue. Maybe comma blue. Gonna clear the transform here. Then the tag that I want is an interactable tag, so that this thing is considered to be something the player can interact with. I don't have a graphic for it yet, so let's go to Components, Rendering, Sprite Renderer, and I want to attach my blue switch to it. So I'm going into this Textures Environment, Interactable. I'm expanding Lever 2, and I'm going to put the lever blue left into there. So you can see that it's appearing right here. The sorting order we will handle with the script, so it will get its own thing that positions itself. Okay. So at this point, we can actually hit play and test. It is an interactable object. Now, we don't have any functionality to it, but if I walk over to it, oh, it doesn't have a collider yet. Need to give it a collider. So let's give it a box collider. And this box, just edit it real fast. And shrink it down so that it's reasonably small like that. I'm going to try to get rid of this offset because I don't really, whoops, I do need that offset. I guess there's no getting rid of the Y offset for this. Okay. So negative 0.3 offset, 0.7 for the X size, and 0.4 for the Y size. And so we've got our box collider there. This should not be a trigger because we want it to be solid. And then we can also give it a rigid body, a static rigid body. And that way it's a physics object that you can't push or do anything with. And now this should serve as something that I can sense. And you can see that that E key pops up when I'm close to the switch, indicating to the player that, hey, there's something that you can probably interact with. Okay. So far so good. Now we've got to start building the script for this switch. And we're not going to... We're going to actually change the sprite in a slightly different way. We're going to actually just store the two different sprites that it'll switch between when you activate the switch. So that is going to be inside of Scripts, Environment, right-click, Create C# script. I'm going to create a lever. And also while I'm here, because I think this is going to be important if we want to have more like things I can interact with, I'm going to create a C# script called interactable. And that's going to be an interface, and we've explained interfaces in the past, but to explain it again, an interface is a purely abstract class. So I'm taking out mono behavior, and actually I'm taking pretty much everything out. So an interface is an abstract class that guarantees the existence of certain methods. So for instance, I could have a button, I could have something I can, a lever, a switch, I could have a pressure plate, different things that I can interact with. And this forces them to have the method called trigger and a method that's called isActive. Furthermore, if I have multiple types of interactive scripts, the player doesn't have to add any extra code to interact with buttons versus levers versus press plates. it will all be interacted through this interactable interface, which saves us a lot of headache. And that's all it needs to have. So I'm going to close this since I'm not going to come back to that. And I'm going to open up lever. So lever is going to need to inherit from mono behavior, but it's also going to need to implement the interactable interface. And so I just add a comma interactable. Now it's mad because I haven't guaranteed the existence of these two methods of public boolean is active and this trigger. So I'm just stubbing those out. I'm going to move them down here to deal with them later. Okay, so the lever is going to operate a lot like the enemy in the sense that it's going to communicate to the to that data script that we were using. So let's start with I'm just forgetting how to spell everything. So let's start with putting that thing there. So we need our public data dictionary, call it data. Then we need to put some of the the public facing variables here. So we need to have a boolean called is activated, and this is just what state the switch is in. So like if you have multiple switches of the same system, these all need to match. That's basically what this is saying. Then it's going to need a name. Now we can't use name. Name is actually a hidden variable. So we'll just call this lever name, and we'll call it default lever. And this is how it will find, anything will find the interaction caused by this. So we're going to rename it once we build it, but it's just going to be called default lever. And then we just need our graphics. What do we call those? Headers. And so the sprites here, we're just going to have public sprite lever left image and public sprite lever right image. Spelled activated wrong. So okay, so we've got our tooltips for all this. Now just for some private variables. We'll go with protected in case we ever inherit from this thing. So So we need the sprite renderer to update the graphics. So sprite renderer. And I guess that's all we really need. And then the offset for its center for calculating its stacking order. So we've got all that. Now we just need to start actually setting up our lever and fulfilling all of its requirements. So first up, let's get these methods here. This is active working and what happens when we trigger it. So is active is just going to return the state of the is activated variable. So it can let you know what state this switch is in. If we were to trigger the switch, this variable needs to switch its state. So that means if it was false, is activated is going to get switched to true. If is activated is true, it's going to get switched to false. So that is this wonderful command. So is activated is set equal to not is activated. So that flips it from false to true or true to false. It's a wonderful little shortcut for flopping a switch. Now we've got to update my data dictionary. So we need to keep track of the state of this switch. And so we're going to do that by accessing data.data boolean lever name, and we're setting that to is active. Remember what I said, that we're going to run that initialize check to make sure that it's properly set up so we can be guaranteed that all this stuff exists anywhere we need to. And we're going to update the graphics. So we're going to need a method called update sprite. And so it seems all you really need to do is change the state of the switch, make sure it's stored into the data construct, and then update the graphic. So let's work on the updating the graphic part. So an update sprite, all we just got to do is figure out what it needs to look like. So if is activated is false, meaning the switch is off, then sprite, we need a sprite renderer dot sprite will equal the lever left image. That was what we were saying up here, is that this sprite, whatever we attach here, is for the when it's not on image. And then otherwise we'll set it to the right image. So update sprite is now satisfied. It's updating the graphics. So that leaves us with start and update. So let's kind of tackle start. Start's going to be one of our more trickier ones. And we can borrow some of our concepts from, I guess let's start with fixing this stacking order. And I want to say that it was probably something we could steal from the doodads. We've got the doodad right here updating its thing. I never remember that formula, so I'm just copying it out of doodads. So let's jump back over to the lever, put that there. All right, so from there, now we've got to, well, I guess we need to, before we even do that, we need to attach everything. So sprite renderer is equal to get components sprite renderer. And I think that's the only thing we have to attach. Yeah. Okay, so we attached the sprite renderer. Now we've got to figure out the state this thing is in. So that means first we need to access my data dictionary and make sure that that initialize check works. So we want to make sure that the dictionary is initialized. Then if data.data boolean, and we're going to use contains. So if it contains key lever name, meaning, because here's the thing with the switch, this could be the very first time the switch has ever appeared in the game, or we could be entering a map where this switch has been in a previous map and we have to load the state that it was in. So we've got to figure out, is this the first time the game has encountered this switch, or is there already data for the switch? So that's what this is doing. We're checking to see if the game already has any information about the switch. And so if it does, so that means the switch name is found. We're going to load the current state from memory. So is activated is equal to data.data boolean accessing at lever name. So that means we found it, it exists, and we can just reference it from there. Otherwise, we're going to set the data to be stored based off of what the switch is right now. And so that allows us to initialize a switch either left or right, and then it will update the memory accordingly. Now, if you have two switches in the same map, one of them is set to be activated, one of them is set to be deactivated, it's just going to pick one, and I think it has to do with the order they're in the hierarchy, I don't really remember. And one of them will overpower the other ones, because this start method runs sequentially. It does call this independently for each object. So that means one of them is going to run this code first and will be the initial switch that it sees. When it gets the second one in the map, well, that first one already set the default state of the switch. And then after we've handled all that stuff, we'll run update sprites to set the graphic to what it needs to be. And then the last thing is to deal with that case where there's two switches in the same map. If these switches are linked, and they're going to be linked by their name, which is very important. If one switch changes, all of the ones on the same system should change. So what we're going to do is we're going to check to see if the state of this switch doesn't match what's inside of the data store. So if there is no match, we're going to fix that. And then once we've done that, we're going to call update sprite to update the graphics. And that should look good. If our switch is capable of moving, it might be worth considering moving the sorting order down there. If your switch is going to remain static, you can keep it there. And so this should link, so we'll hit save. Now, we don't actually have any way for the player to interact with the switch. And so let's go and fix that. So under the player interaction script inside of update, that's where we're going to want to handle this. And so that kind of leads us to wondering how we should handle these buttons. So if we go to project settings and we take a look at input. So there's no current like use button, and that's something we might want to consider adding, because there's like a fire button, there's a axes and all that stuff, but we might want to consider increasing this up one more size, and that adds this debug horizontal here to use button. There is no negative button. The positive button is going to be E. Let's kind of mimic this fire button to see its settings. It's a key or mouse button, x-axis. Well, that looks pretty similar. Okay, so we've got use button. And let's go and see that. It's set to E, and we're doing it this way to allow the player to change the keys, because this input manager is what gets linked into like a key rebinding system. We don't want to hard code E into the code, because that's really lazy. Painfully lazy. So we're going to the player interaction script inside of update. So if input dot get button up, so on the releasing of, did we call it use button, I think? So alternatively, you could just use like input dot get key up if you wanted to. All right, so if when they release this up button, we're going to get all the interactables within range. So collider 2D, yeah, we'll just call it things, equals, so we've done this before. It's a physics overlap sphere. Overlap circle. It's 2D. And actually we want to do, let's see, transform dot position plus get components circle. You know what? Let's just make this separate pieces. Let's create a vector 2 called position. Ooh, and that will be set equal to transform dot position plus the get component circle collider 2D dot offset. So that's calculating the offset for this. Then let's get the radius, and that's just going to be the circle collider's radius. And so that's a little bit more cleaner. Oops. So it's going to get a array of all the different colliders within this radius, and that's based off the center of the player, but adjusted for that collider. Now, it could be worth considering maybe I needed to just slide that down in the player prefab, but it's going to be fine how it is. Anyway, so we get our list of things, and we will for each through all of them. For each collider 2D item in things, if that item is an interactable, then item dot get component And this is where that polymorphism of the interactable script, that interface comes in handy, because I can just get type interactable and run the trigger command. And no matter what type of interactable thing it is, it could be a button, it could be a lever, it could be a switch, it will function for this. So that should send the message to activate to everything inside this radius. So I'm going to save that. I'm going to go back and test this. So I'm going to rename this lever from, oh, I need the script on it. So let's put the lever script on it. And if you want to move it to the top, you could. So we've now attached this script here, and it needs a link to the data object. And we need to set up the sprites for it. So I'm going to take the left blue. I'm going to take the right blue and set them there. And I'm going to give it a name and call it blue lever. So anything that's going to share that blue lever name is going to be linked to this. And that's what we're going to do in a future video. We're going to link some walls to this. So we hit run. And ooh, it is not updating itself. Let's see. Did it get an error? Spell it correctly. Let's make sure the player has everything right. And that should be fine. Unless it's possible to switch. No. Oh, it's probably related to my detection of the button pressing. So, use button could be the problem here. And that's probably it. Needs to be a key or mouse button. And so we've got a switch that switches back and forth. The beauty of this, let's turn this into a prefab now. So I think I might need a new folder for my prefabs called environment. And I'm going to move this lever blue into there. And now if I were to put multiple of them in here, what we're going to see is they're going to remember the states. And I'm even going to put one down here inside of this other map. And those levers will persist, and that's going to become incredibly important down the road. So we're going to see that when I activate one lever, all levers change. And then if I turn on this lever, you can see that it's staying turned on over here. If I turn that one off, these ones turn off. That's going to be incredibly important for our stuff down the road. Anyway, if I activate this, and we can also see that we can change the initial state. I will have to change both of these because otherwise they fight, so all of your switches have to match. And you can see that I could start it in this state if I wanted to, like kind of an on state. All right, excellent. So that's going to be the normal conclusion for this video. If you want to stick around for some sound effects, that'll only take about 3 extra minutes. So if you've been doing the sound effects from the extra video, stick around and we're going to do that real quick. Otherwise, if you didn't do sound effects, some of this probably won't make sense because we're going to be building off of our existing sound effects interface. So, sound effects. Pretty straightforward. We want to go take a look at our sound player. And I want to add one more script here, or one more clip. Public audio clip. Audio underscore activate. And that's going to be kind of a generic activate sound. So we're going to hit save on that. It adds a new clip that we can then start using. Oops, I should not have closed that. Go to our lever. Let's open up the prefab for it so all of them get it. And I'm going to attach the sound player components right underneath the lever. And you can see it adds all those other separate ones. But I'm only interested in giving it the switch metal sound under activate. So I attach that. Okay, now let's go and open up my script. It's going to be very easy to get this all finalized. So we need to create a entry for the sound player called sounds, and I need to attach it here. So once we've linked it there, all I've got to do is just inside of the trigger effect, is do sounds dot play one shot, and we want to play sounds dot audio activate, and that's going to be the switch noise for when we activate this. So I'm going to hit save on this. Jump back to here real quick. I'm going to turn it down a bit because I know this is going to, the switch, it defaults the sound audio source to be like 100%. Let's go more for like 20%. And now that attached it to all of them, so they now all have the sound. So when I activate it, if you're listening very carefully, you should be able to hear that. And so now we have some sound, and you can even see that the stacking order is looking correct on this. And so that's going to be the true end of this video. Now that we've added some sound component to the switches. Off camera, I'm going to go add another set of switches, a red set, just to demonstrate that they can be, you can have multiple sets of switches and they don't hurt each other. So next video, we're going to take a look at doing the walls that are based upon these switches. And there's a lot you can do with these switches. You can kind of configure that script however you want. So see you for the next video.